Bye bye. So Nikitas, you can share your screen. I will mute my microphone.
Yeah.
Perfect. So I'm.
Is that okay? Does that show all right?
Yes, yes, we are seeing you.
Excellent. Would you like me to start at 5? What should I say, 6 on the dot?
It's up to you. There is some people connected with us.
Well, I'll let everybody to have a quick break between.
Yeah. Maybe it's time to a coffee or.
Yes, get a coffee or comfort break.
Perfect.
Right. Let's make a start.
Yes.
Well, good afternoon, good morning, or good evening. I think we probably have participants from all time zones. So thanks for joining wherever you are. This is the first for me in Luxembourg. So hopefully this will be one of many coming up, and I look forward to meeting you all in one of the physical events. So presentation that I put together is around high availability, scalability within our logistics platform with 19C, Oracle 19C, and Goldengate 19C. Oops, bear with me. Looks like, oh, here we go. So agenda for today. Bit of introduction, a bit of business context on who we are, well, and how this came together. Around that to get the best out of all the premier product suite within Oracle High Availability and Scalability. How Goldengate classic architecture and microservices architecture fits within that, and where multi-tenant plays a role, where you can use it, where you can get some benefits. The evolution of our platform with the autonomous database that Oracle is, Oracle's probably biggest differentiator for the time. And, a few points on lessons learned. So basically what we learned from this design and deployment. So just a little bit about me. My name is Nikitas Xenakis. I'm a platform specialist and architect for the Co-op. The Co-op is a leading convenience retailer out of Manchester in the UK. I've been doing and working with database technologies for pretty much close to 20 years. I've been doing customer advisory for Oracle Database, RAC, and data integration for Oracle, and doing some beta at the same time. And I also sit in a group of global leaders for transaction processing and analytics, part of the ACE program, and my social media handlers. If you would like to connect, get in touch, feel free to do so. Twitter, LinkedIn, whichever you prefer. So just a little bit about our company. We've been in the UK, founded in 1844. It's not a PLC, it's a cooperative, if you're familiar with the concept. And it just basically started from a few individuals that wanted to cooperate and bring something more to the table than just profit. This is top right is how our stores used to look like back in the day, and this is one of our Didsbury stores in Manchester. But enough about what we were and how we look like. What does the Co-op look in 2020? As you can imagine, the company is modernized. So we've got an annual revenue of 10.9 billion. We've got a business that spans across retail, wholesale, franchising, and e-commerce. We've got 2,800 of our own stores. We've got 14 of our own distribution centers, which is growing. And we have a logistics network which is servicing not only our stores, but through our wholesale and franchising proposition, close to, well, in excess, I should say, to 10,000 outlets. By the way, this is our beautiful head office building, built only a few years ago. But what's our modern business demands? And as I said earlier on, I want to give you a snippet of our business context so you can understand how high availability and scalability fits into this context. So, we constantly enter new markets with wholesaling, franchising. We did start as a pure retailer. So now that business proposition is growing. So we need to grow. We want to be fit for the future, so we always continuously improve wherever we see opportunities. We try to bring all the efficiencies back to the business. So whatever we take cost out of the business, we try to invest it back. As an example, the whole investment in high availability, Oracle RAC, Goldengate, and all these premier technologies. But also we use technology as an enabler and a transformer, and more recently as a transformer. So you can see some of our initiatives: the green bike for home delivery, some of our wholesaling partnerships with Cost-Cutter and NISA, which extended our wholesale proposition to by around 4,000 stores in the distribution network. But also at the same time, we connect with new customers, so the millennials. So there is a co-op store, if you can imagine, not only in every pretty much postcode in the UK, but all in all the major festivals in the UK. Some of our newest technology that we're trialing, the autonomous robots. So that's a proposition that we're trialing in the Milton Keynes area in the UK. If you're familiar with Milton Keynes, it's just 45 minutes outside of London. So basically, using this app, you place an order, we pick at the store, we deliver those goods into the autonomous robot, which is delivered at your doorstep. At your doorstep. With the app, you unlock the robot, and the store basically is with you. Estimated time around 9 minutes. We don't currently cover the rest of the UK. We had to pass some legislation for that technology, so that's currently on trial in one of the counties, as I said, in Milton Keynes. Our technology strategy, as with everyone, I would think, you might find that quite relative to you. We want to do things faster, trusted, and leaner within our one core principles. What does that mean? Faster. For the logistics network, well, we want to be able to open new depots and be agile and do these things in high velocity, because we want to be able to cover our customers and colleagues to the best of our ability. We use cloud, and we have footprints in all three major clouds: AWS, Oracle, OCI, and Azure. So we want to trial things without significant investment. So cloud is perfect for that, I'm sure. I'm not saying something new here. Where this presentation aligns closely is we want to be trusted. So the enterprise, of the future is always available. That's the expectation now. That's the status quo. No longer we can afford any downtime. So continuous availability and scalability is key, but at the same time, we want to do all these things in a secure manner with predictable performance. Leaner, it's all about cost efficiencies, but also it's about simplification and standardization of our platform. So this is where maximum availability architecture, Oracle RAC, DataGuard, this is where they all come to play, where our database platforms are now standardized and simplified using one set of technologies. And as part of that, we are looking to exit data centers because the business of running them is quite expensive, and that's where obviously cloud adoption comes into play. So in a nutshell, that's our kind of business and technology context. We have two data centers still, separated by 12 miles apart. We've got a footprint on all major clouds, as I mentioned earlier on, but we've got a support center of 4,000 users, coverage around 6,000 members, which continuously connect to those systems. And we've got a number of our own stores, and through wholesaling, independent stores included. So if you go back to those all initiatives that I've been discussing in terms of wholesaling, franchising, retailing, and e-commerce, the one thing all these initiatives rely on is a highly available and scalable logistics platform. There's no, no way that we can deliver all these goods to the stores, to our stores, or to our partner stores without investing in that platform. And just to give you the wider context, this is the coverage of our distribution centers. With a little bit more focus on, if you're coming from a logistics background, we do ship around 11.5 to 13.5 million cases a week. At all those picking transactions at those distribution centers must complete around in less than a second. And that attributes for 98% of those picking transactions. At the same time, the real-time operational capability we need to provide equates into in excess of 500,000 requests a week. What does that mean? Well, when we sat down with our business colleagues, and by that I mean, well, the fact that high availability and in extension maximum availability architecture is a little bit understated at the chief executive or perhaps at the board level. So when I sat down with my business colleagues, we tried to quantify the actual cost of downtime for each of our distribution centers. For the case of simplicity, we call a depot a distribution center, and we have, don't forget, we have 14 of those. So the cost of 20 minutes downtime per depot is close to 5 figures. The cost of 20 minutes downtime per 7 depots, and I will explain why 7, because 7 depots are actually serviced out of one of our data centers. The remaining 7 are serviced by our second data center, which means both data centers run live applications, as opposed to perhaps some of deployments out there that use one data center as their primary and the second data center as the standby, is in the 6 figures. The cost of more than 20 minutes of downtime per 7 depots is in the 7 figures. So you can see how availability or loss of availability at the distribution center, how expensive that becomes by the minute. Anything more than an hour is incalculable. Basically, it will take us weeks and weeks to recover the supply chain, and all that means is you end up with stores with empty shelves, and that that loss of revenue is incalculable. So that's when that's what matters when you start investing in high availability and maximum availability architecture. Because the investment in technologies like Oracle RAC, Goldengate, Active Data Guard isn't cheap, but you have to justify those investments to senior and executive management. So from our point of view, we want to be able to cover DC outage, human error, hardware failure, and any system failure, including logical data corruptions. In terms of scaling, I think it's more to the points that I covered earlier on. It's about extending the logistics distribution network with more depots to cover more and more areas in the UK as we grow as a business organically and through acquisitions. It's about, in the case of COVID, we've seen an unprecedented scaling of our systems from a demand perspective. So you can imagine for 3 months we had almost every day being a Christmas Eve, which is one of our busiest days in the year. It's about growing the business at the end of the day. So technologies like ASM, Oracle RAC and Goldengate, using both vertical and horizontal scalability allows us to scale. And I should point out at this point, we can still scale based on the requirements that we have for our applications with physical hardware. So, virtualization isn't the only way that you can scale. Keep that in mind while I take you through the architecture further down the line. So where does MAA at the platinum level come into play with all those demands? Well, when we try to put that together, and I'm not sure how many of you are familiar with maximum availability architecture. I will assume that you are at least vaguely familiar. You can give me a thumbs up or down if that's the case. But all it is essential, and I'm not going to go through it in great detail, all it is essentially is a set of blueprints trialed and tested by Oracle to cover HA, DR in a variety of tiers, depending on what your business demand is. And the point that I'm going to cover more is the platinum level, because that's where we are from a business perspective for the logistics platform. It does cover, the blueprints do cover on-premises deployments, OCI deployments in both virtual or bare metal configurations, and it's it can be applied in commodity or engineering systems as well as the Oracle Cloud. How are we doing with time? 15 minutes. Okay. So when you do put that architecture together for your business or for your solution, the key considerations to ask is the obvious ones: RPO, recovery point objective. How much data can you afford to lose? Can you live with perhaps 1 or 2 minutes of data loss, or perhaps 30 minutes? What about your RTO, downtime? How quickly should you be back up? What's the downtime that you can afford? And more importantly, when you're back, in case of a disaster, can you survive with degraded performance? Let's say your disaster recovery side was 75% or perhaps 50% of the capacity. Your primary is, can you cope with that, and how long can you cope that for? What's the perceived application outage? So what does that mean to the end user? Are you hiding the failover and the switchover? Is it transparent or not? All these things are very important questions you should be asking your business and your technology colleagues in order to come up with the best architecture. For us, and for me specifically, the RPO is 0. So we can't afford any data loss. That's technically inventory loss. Downtime, that's 0. As I explained earlier on, every minute of downtime is hugely expensive. The performance after the event, either in HA or in disaster recovery scenario, needs to be identical. So we have identical capacity in both sides. And the application outage, well, on this one, we're a little bit flexible. When it comes to HA failover within the same data center, that's transparent. But when it comes to full data center failover, that is because of the way the failover is managed, that is visible. So we control that through business continuity practices. Excuse me. Yeah, here we go. So our strategic architecture on premises, just to give you a very quick view, we've got a load balanced OHS tier at the DMZ. As you can see, each vertical represents our data center. Excuse me. Then you've got a three node cluster for your fronted by a load balancer and NetScaler. So that's a 3-node web tier platform fronted by a 3-node WebLogic cluster, and the 2 WebLogic clusters on each data center are independent, so you can patch them and maintain them separately. and you've got 2-node rack, minimum 2-node rack per site, with data guard for disaster recovery, active data guard, and Goldengate for some of our special cases, which I will explain in a minute. From an HA/DR perspective, if you were to do this in OCI, which we are trialing at the moment, a few areas, you would that architecture can look very similar with OHS or Nginx for your load balancer as a service. You would use WebLogic cluster through JCS, and you can use 2-node rack database with optional FARSync if you need to provide zero data loss at any distance. So our strategic MAA design patterns with 19C, you've got the option to run up to 3 PDBs. So hence the two preferred patterns is a 2-node rack with 1 up to 3 PDBs in one CDB. Use DataGuard and WebLogic for your middleware. We do use ACFS and HANFS over ACFS in cases where we have to share flat files or any application files that the application tier needs to share between the 3 or more nodes. The use case that I will, you have also the option to configure transparent application continuity, where you can use GridLink if you're using WebLogic, or a more standard approach for non-Oracle middleware. Again, if you were to do this in OCI, it looks really similar. And one of the latest offerings in OCI, which is something we've been trialing, is the WebLogic deployment through Oracle Kubernetes. I would recommend that for highest degree of consolidation of your services at the middle tier. In the case of the database layer, the patterns are very similar. Again, it's one PDB in one CDB with a 2-node rack for primary and standby, and Goldengate where you've got those demands. So a bit more detail on our challenge and use case. So if you remember back to my point, this is about logistics, warehouse management. So the demand and the requirement we have is to be able to complete 95 to 98% of our picking transactions on each of our 14 depots in less than a second, while at the same time provide real-time operational reporting capability to all those 14 depots without affecting any online operations. So all these picking transactions need to complete in less than 1 second without any disruption by the real-time operational reporting or any analytics that the support center needs to undertake. The second and equally important requirement that we had is, well, how do we do zero downtime upgrades? And this is where Goldengate comes in as well. That capability to do the online upgrades is to minimize the disruption, obviously, in each depot. So we use Goldengate to do that. That minimizes the outage significantly. So if I was to give you and I should have said that in the beginning, although my presentation has got the title of Oracle 19C and Goldengate 19C, it is applicable from 12C release 1. So you can apply that all the way from 12C release 1 to 12C release 2, 18C, and 19C. The architecture can support all these versions. So if I can take you through this diagram in a bit more detail, we've got, if you can remember, each of those verticals, and I hope that you can see so you are able to see my mouse. So each of these verticals represents our data center. So there's data center 1 and data center 2. We have primary, so 2 primaries, one in each data center. So that's primary 1. For the sake of this presentation, I'll call it source 1, because I have, sorry, because of references further down the line. So that's source 1. So that's a 2-node rack with an active data guard standby on data center 2. Then you've got the second source, primary, again, 2-node rack with its active data guard standby back in data center 1. And then we have, so this is for the transactional picking systems. Okay, so you got source 1, source 2, each of those with an active data guard standby. And you've got a target, that's our Goldengate target, in one of the data centers with an active data guard standby in data center 2. We use, obviously, the active data guard standbys are for disaster recovery, but also in the case where our Goldengate target needs to be offline for either plant maintenance, configuration changes, etc., we can point with no downtime all the real-time operational reporting to the active data guard standbys while we action our maintenance, and then we can point them back. The way we do that is through services. So we down the service on the target, we repoint it back to the data guard standby, and vice versa when plant maintenance is completed. Each of those 14 depots, and they are split in 6 per site, which is the initial version, and now we have 7 per site, so each of those depots runs as a distinct application in each of those source databases. Now that runs using singleton services. So there's 2 applications, let's call it 2 applications that comprise the transactional component of that system. Each of those has got a schema, and each of those runs in each node. That way, due to the application certification requirements, that was their best recommendation for deployment. So each of those runs with singleton services, and we can run all 7 on all 7 depots in one node, and vice versa. So we've got 7 distinct extracts, pumps, and replicates. 3 on node 1, 4 on node 2. The same deployment method on the second source. I'm sorry, I should show this one. All getting replicated into 14 replicates on your Goldengate target. That means we can scale vertically. So the more depots we deploy as part of this consolidation model, and I should say this works in its first iteration. It works on a schema consolidation model. So each of those will be replicated on 14 targets. Back to my point, what I was mentioning earlier on, each of those schemas has got its own extract, pump, and replicant. That way, not only we can scale vertically for Goldengate, we can scale horizontally with Oracle RAC, and also we eliminate all single points of failure where each of those depots, each replication can be configured and taken down for maintenance without affecting any other configuration of any other depot. If you were to do this with 19C, the architecture will look, as I said earlier on, identical. And this is where we are now. If you've got any questions, feel free to put them on the chat, and we can take them through in the end. But yeah, as you can see, the difference between 12C and 19C from a config perspective is really, there's not much difference. A little bit more detail on what I've taken you through. I think I've tried to put it in one slide for you to take that away. So all instances, we try to balance them, for the vertical and horizontal scaling. I should also point out that we use active data snapshot standby to resolve any data issues in case you've got any logical corruptions. Obviously, we don't want to flash back the primary, but what we do, because it's a schema consolidation model, what we do is that we use the snapshot standby to flash back the database to a point where we know that the data was in a good state, extract that data, and resolve all the data discrepancies on the primary. That way, we maintain high availability across the board. Back to the point for GG maintenance, we can do connection redirection between Goldengate target and active data standby for plan maintenance or any lag resolution issues, which sometimes you get through integrity constraints or other. Important point to make, the architecture, if you're an Exadata shop, you can implement the architecture using Exadata, excuse me. If, on the other hand, you're more of a commodity shop where you build everything yourself in your enterprise, no issue, you can implement that architecture in the same way. And if you're using OCI through DBCS, that is still, that can be implemented in the same way. You do have, if you are in OCI, you do have the option to use Goldengate Hub, which is a slightly different architecture with the ones that we use now. And that's more, the way I understand, that's Oracle's now strategic architecture going forward. In terms of other considerations, as I said earlier on, we do use schema consolidation for resilience and better performance. We do use dedicated network, both at the data center, but also at the depot to data center connectivity. We use quality of service to protect the voice traffic for all these important transactions. So not only we need to have stability in the database and middleware platform from a performance perspective, but we need to have a very stable and reliable network because because it's a centralized solution rather than a distributed. And we do use dedicated compute and storage, again, for risk mitigation. On to Goldengate, which is, again, as I was mentioning earlier on, an integral part of this architecture. I assume, again, that you're more familiar with Goldengate, so I will just pass it through, perhaps not in great detail. It is a log-based change data capture replication technology. It is declarative with transactional integrity. By declarative, I mean you don't have to write code to replicate table A to table A from source to target. It's all config based. It is heterogeneous, so you can have Oracle for source and targets in either the same version or different versions, and I'll explain how that has been tested from us. Or you can use it with heterogeneous, so Oracle and non-Oracle with source and target. It's part of the Fusion middleware as well as the database server core technology group, and it's very well integrated with Oracle Database 12c all the way to 19c. The classic architecture, if I can quickly take you through it, basically you have your source database where the Goldengate process will mine the logs and generate trail files. The extract process will mine the logs and generate the all-important trail files. The pump process will pick up those trail files and ship them over to the collector process on your target. The receiver, the replica process will pick those up and apply them to your target database. There is a manager process which is responsible to keep those services up and running. Why use it? I think I've given you many reasons of and use cases for to use them. I will stick to the ones that we use, which is a combination of unidirectional and consolidation pattern. So for real-time operational reporting, but at the same time consolidating all the transactional information onto a single data repository, not only for real-time analysis, but also for offline analytical processing. The second pattern, which again falls into the unidirectional, is the online upgrade. How did we decide to use it? Well, you can argue, well, why do I need Goldengate? Why don't I do everything with Active Data Guard? Well, we did a due diligence in terms of cost and licensing, because Goldengate is not a cheap product, but you get a lot more than what you get with Active Data Guard for an extra 4K in the case of our due diligence. And it's not just the fact that obviously your target is open. You can have your source and targets maintained separately, upgraded separately. You can have heterogeneous model between not only different versions of Oracle, but also if you decide to use a different technology for your target, not that you would want to, but equally important, you do have the option to do replication granularity, which means you don't need to replicate the whole schema. You can replicate a subset of your schema. So plenty of reasons and all these we put together into a business case in order to justify the investment. Why did we use it? Well, I think I've pretty much covered that. It's a combination of unidirectional and consolidation, but also combine it in an MAA fashion with Oracle RAG Data Guard. And just to give you a high-level view of the amount of real-time operational reporting that goes on a daily basis and on an hourly basis, you can see all that from pretty much from all 14 depots. That's over a 24-hour period and over 7 days. Implementing it, which I'm sure some of our audience is probably interested to hear. Well, if you are looking to do this with 12c release 1 or 12c release 2, which is how the platform started and evolved into 19c, our database tier was Red Hat 6.5, Oracle RAG non-CDB 12.102, with Goldengate 12.2 classic architecture. We use Data Guard in fast sync mode, and we use the DBFS, the all-important DBFS, which is available only on Linux and Solaris. So if you are considering to do this, keep that in mind. So DBFS is a pseudo file system, which is the all-important component to store the trail files and config files for Goldengate and make them self-inclusive into the database as a means of, through means of binary large objects for HA failover and switchover. So both for HA and disaster recovery. Our middleware platform for the use case is non-Oracle. So it's mainly based on JBoss and some custom C and C++ components. And that was due to a third-party certification for accessing the Goldengate target. I think also the reporting tool, again, for reference and for those that are interested, it was based on Cognos. We started using actually OEM 13.2 to manage both DB and ggpack. From a 19C perspective, if you're looking to do this in 19C, we use Red Hat 7.5, Oracle Database 19.3. Again, non-CDB for certification requirements. DataGuard, active DataGuard, should I say, in fast sync mode. Goldengate 19C 19.1. Again, using DBFS for the all-important trail and config files. On this one, you need 9.1, the grid infrastructure agent, which is the all-important component that almost like a glue that connects the GG resources with CRS. So what should you expect from your platform? Again, just to give you a good idea of what does that look like at the CRS level. Excuse me. You can see the DBFS resources, 1 per node. You can see the Goldengate services, 1 per node. You can see the Goldengate VIPs and resources, 1 per node, the application VIP resources. And you can see on this part, the singleton services, 1 per node. So you can see 2 different services. Source B looks identical. Again, DBFS, Goldengate VIP, Goldengate resource, Goldengate service. Excuse me, my laptop is going a little bit slow sometimes and it's not flicking between the slides. Goldengate target. Now, again, you have your DBFS resources, 1 per node. The services, the VIPs, and the resources. I should actually point out that from an application perspective, although source uses singleton services, the target uses active-active. So you have actually services for each depot that run on both nodes for scaling. If you were to, if you're looking to manage this, again, simple administration tasks. If you are looking to stop Goldengate N all the way up to the database layer, you use AGCTL to stop, first of all, the Goldengate service. Then you stop through CRSCTL the DBFS resource. Then again, through CRSCTL, you stop the Goldengate VIP. And then you stop the database. If you were to start everything, it's a lot simpler. You start the actual database service. So think of the database service, the one that actually has got all those 7 depots consolidated. That, based on the dependencies that has, that will pull all the previous dependencies and resources that you've seen. So that's a lot simpler. Sometimes the Goldengate resources don't start on each node, so you may have to relocate the service. It's one of the little things that I found out. If you were to log on to GGSCI, which is your Goldengate command line interface, you can see that each of our depots has got an extract and a pump. So that shows host 1 with 4 entries. So 4 depots, 4 extracts, 4 pumps. Node 2, as I was saying earlier on, that's 3. So that at the moment that's not balanced, although we have more depots and we will balance those. Moving on, so that's source B, host 1. Again, you've got extract and pump for each of our depots. Our depots are actually denoted by this 2-letter mnemonic. So again, you've got 3 and 4, but don't forget you can run all 7 in one node if you're doing maintenance. Target, you got 7 per node. So that's 7 replicas, as you can see them. And 7 on node 2. If you're looking to do some monitoring, GGSER is your best friend. It's almost like the alert log for the database. That's got all the errors, the all important errors. But if you're looking to diagnose issues which have to do with extract, pump, on replica, there are specific report log files per depot, so per extract, pump, and replicate, and per depot, which you can investigate and grab, how many records have I processed and things like that. If you are investigating performance issue, it's important to look AWR between the time of issue, CPU, network, just to get to the bottom of your issues, which could be a lot more complex than just a pure integrity constraint. If you're monitoring lag between source and target, that's a very useful view to look GG lag history. And if you run that command, I've filtered it out with LG, which is one of the depots, and that will give you an output similar to this for your lag. Oops, excuse me. So yeah, that again, you can see that all the other depots, so PH, AM, each of those showing that extract to pump to replicate. Moving on, so this is the classic architecture has always been there first. Microservice architecture is the newly and the more strategic architecture for Goldengate. That's just a reminder of the classic architecture. And the main differences in the microservice architecture is that pretty much all the services are REST enabled. So you still have the core foundations of the classic architecture with extract, which mines the logs and generates the trail files. Distribution server is what we used to call the pump process. You've got an additional process for metrics and service, which manages some of the performance statistics, as well as the service management element of the resources. And the receiver replicate, again, are very similar. The main differences, which is how we, a piece that we use to evaluate, is that it's very much simpler to administer. It's got a single web interface for all your sources and targets, rather than the classic architecture where you have to install and configure Goldengate on each database node. This can be done pretty much, its management, should I say, can be done from a single web interface. With classic architecture, you have to kind of log onto each individual source or target node in order to investigate. It's fully REST API enabled, so if you've got, if you're familiar with JSON notation, you can actually set up all the configurations, extracts, pumps, replicates, and your configurations through JSON. You can actually manage the stopping and starting as well remotely, because that's what actually that single web console does behind the scenes. The part that I like the most is that it's more secure. So you can actually have segregation of duty between your core sort of infrastructure DBAs and perhaps the DBAs which are more application and closer to the application, which manage purely the configuration, i.e. the replication, table A from source to target, or schema A from source to target. But all the learnings that you've got from classic architecture, they can still be applied with microservices architecture. Very important to state it. The reason why we've adopted it is because it does cloud enable your architecture, so you can for future hosting and our data center exit program. So some of the scenarios that we run with microservices architecture. Scenario 1 is a 12.102 source, non-CDB, onto a 19.3 target, using exactly the same config that I've described earlier on. Scenario 2 was a 19 to 19. So, sorry, I should have said this was the scenario where we kind of simulate a database upgrade from 12.1 to 19. And scenario 2 is to trial and test the new kind of the latest 19C stack. So that was a source 19.3 to a target 19.3. But again, that was non-CDB. Design to deployment in approximately 3 weeks. So again, if you are familiar with Goldengate and you're looking for the microservices architecture, I would encourage you to to get on board. We've tested planned and unplanned scenarios quite successfully with both source node failover and switchover, target node failover, source database switchover and failover, and target database switchover and failover. But again, non-CDBs are kind of going to be probably phased out as we move along onto 20C. So started looking at multi-tenant and how we can leverage that, not only for the whole strategic direction, but also for maximum consolidation and tenant protection. I do like the fact, obviously, that we can recover quicker with flashback at the individual PDB rather than having to use the snapshot standby. But also, as Oracle develops the multi-tenant architecture, the ability to do a single PDB switchover for audit and risk requirements, it was one of the things that actually has forced us to look at in more detail. It's quite complex to have to coordinate 7 distribution centers to do a disaster recovery test every year. So having to do a single depot is always highly beneficial. How does autonomous play into the evolution of our platform? And I've noticed I've got 9 minutes, so I'm going to try and finish 5-2 so we can have some time for questions. So why autonomous? Well, here's my thoughts on it. And the specific use case I have is an externally facing application, as opposed to the logistics platform that I've taken you through. But that doesn't mean that we won't be trialing and testing it on the to set and underpin the logistics set of applications. It is the quickest path to Exadata. So I think if you're not familiar with Exadata, it is actually within 5 minutes you've got an Exadata based database. So that's great. For externally facing applications, you get all the patches straight away. You get all the security updates. You don't, that's a big headache from a security and risk perspective. One that compliance always is on our case, and that's a big benefit for all us enterprise DBAs. It's fit for purpose, and the part that I like is the auto scaling. So if you've got something that is that you can start small, you can scale automatically. You don't have to incur downtime for that. Why and what are the challenges? Well, I think the serverless option is shared, so that you have to come into grips with the fact that you are sharing resources with others. The dedicated, I think, will be more fit for purpose for mission critical. Also, I think there's a couple of developments which, again, I might not be 100% correct on this one, but to the best of my knowledge, the ATP is only available in one domain, and I think the Active Data Guard standby was in the roadmap. It may have been delivered, but not to the best of my knowledge at this point in time. So the cross-region capability is restricted. Some of the specifics and callouts is that obviously if you've got applications that have got legacy code, that have got that deal with UTL file, SQL Loader is not currently available. You can use Data Pump, you can use external tables, but you can't use SQL Loader. So you have to think the way your application and all these loading routines work for you. Some specifics to my use case. So you have to rethink the way you write your PLSQL uploads and downloads using UTL file. You have to create a private bucket, and you have to use DBMS cloud package in terms of to in terms of managing that inbound and outbound process. Disaster recovery, although I've covered that extensively, I think all I wanted to mention is actually this part, which the source failover for Goldengate is quite straightforward because you're still pointing to the same target. But in terms of target failover, that's a little bit more complex because that is relying on the target database to have a role-based trigger from primary to standby, that firing over a database link, a DBMS scheduler that fires a PLSQL procedure, which changes the VIP of your source, of your Goldengate source. So now it starts to pump and send the trail files to a different target. So that's a little bit complex, and it does require a bit of wiring. So I think that's got a little bit of room to be simplified. From a management perspective, we use Enterprise Manager in high availability mode, in maximum availability architecture mode, and we also use the always-on monitoring for patching and OEM, but at the same time receiving notifications. Lessons learned. I think the main thing is to prove it works. So test all your scenarios and make sure that you check with this Oracle support document, which validates your application schema if it's a good candidate for replication, for Goldengate replication. That just checks a number of things, including some of the data types that perhaps you have some restriction. Future plans is the Goldengate Hub, which is the way I understand the strategic direction, and also utilize more of the MAA stack, specifically AHF, the Autonomous Health Framework, and migrate from Red Hat to Oracle Linux so we can patch the kernel, especially for security updates without downtime. And just to conclude, for the co-op, for the leading UK convenience retailer, the MAA investment has paid off. We had several planned outages, several BIOS upgrades, unplanned outages, server failures without without any downtime. Everything failed over transparently. We had human errors as well, which we recovered using snapshot standby. So, the impact to the business was zero. And I've been quite vocal and open about it in social media. A little bit more, if you want to read more on MAA, I've just got a couple of links. And that's me. I wanted to thank you. I think I'm just under an hour, and we've got a few minutes for questions. Thank you for listening, and I hope you enjoyed it.
Thank you, Nikita. We enjoyed a lot. Actually, we have two questions.
Sure.
One, why not OGG 19C with ACFS? Any restriction or limitation from your side?
So if you use ACFS for managing trail files, that is outside the database. So you have basically you have to do two separate failover mechanisms, so to speak. So you have to fail over the database, and then you have to fail over the storage using ACFS replication. When we put that together, when we put the architecture together, we want it to be as simple as possible. So we thought DBFS, was the right thing to do at that point. However, we are looking at this now with the Goldengate Hub architecture because that's reliant on ACFS.
Nice. And the last one was, how did you upgrade your DB tier from 12C to 19C with zero downtime? And if you can highlight the steps, yes. Just the high steps.
So I think that qualifies probably for the separate presentation, which I will start writing now. But basically, we built two clusters. So there was a Source cluster was 12.1. I think it's one of the slides that I'm explaining. The target cluster was 19, and you install Goldengate 19 on each of the clusters. You have to upgrade GI at source because you have to use the grid infrastructure agents at the latest version. So you have to upgrade 12.1 GI to 19 while you build 19, almost a vanilla 19. And then you configure in the same way you have your extracts, pumps, and replicates for your Goldengate replication. Rather than do a set of tables, which we did, we extended that to the full schema. I must admit, we are fortunate that when we pass through the application schema through that Oracle support document, we didn't highlight any conflicts. So no weird data types that would stop us to do that.
Okay, thank you.
But you gave me a great idea for the next presentation. That will be
in fact, it was not me.
Upgrade.
It was another guy from audience. The guy.
Okay, well, that's great.
Hangapavan, I think, if I said correctly.
That's a great question.
Thank you, Nikitas. It was an amazing presentation.
Thank you. Thank you for your time, and thanks everyone for joining. And
see you soon.
Thank you.